Morning, guys. All right, here we go. Or afternoon. I don't know when you're watching this. It's morning for me. We are going to start our brand new chapter today about the Pythagorean theorem and right triangle trigonometry. So I'm going to open this one up here. First thing that we are going to talk about is the Pythag theorem. I like to do the THM to shorten the word theorem, and it's Converse. We're going to do that on 72, 73, and 74. But I'm actually not going to start on 72. I'm going to turn the page and start on 74 right at the top here. So what the Pythagorean theorem says is essentially if triangle ABC is a right triangle, then a squared plus b squared equals c squared. And it's a real basic theorem. Like, looking at it might not seem like there's too much going on there, but we have to understand a couple of things about geometry and what's proper to do. So firstly, with an if-then statement, you have to have that the if part exists, and then you can do the then part. Okay, so like I need to be looking at a picture of a right triangle, and I'll know that I am because it'll have a little box in it. Or like they have to tell me that I have a right triangle. Now the other thing that's a little bit kind of weird, but like mathy, I guess, is when we're naming any triangle or any shape really, you start at a vertex with a capital letter and then you work your way around clockwise. And then the other thing that's kind of appropriate about naming a shape is, so since I started with capital letter A here, the side opposite of it would be called lowercase a. Just so that you, like, opposites are super important in geometry, and so like that kind of just is a helpful thing. They're both the same letter. One is capitalized, one is lowercase. So like across from B, we'd have lowercase baby b, and then across from C, we have lowercase baby c. So like understanding those things, then our little equation over here, a squared plus b squared equals c squared, makes a little more sense because now we understand better that these three letters are talking about sides of a triangle, and specifically the two that are being added are the legs, and the one by itself is the hypotenuse. And the hypotenuse always has to be across from 90. That's the way I always think of it. Not necessarily the longest, although it is. It's just hard to sometimes tell by just looking at something that it's the longest. Always opposite 90. So let's start with that. If we jump over here, same Pythagorean theorem, super cute. If we open that one up, we're just going to try a bunch. So I have a right triangle. I can do a squared plus b squared equals c squared. We're going to put the legs in for a and b. So 3 squared plus 6 squared. And then I don't know the hypotenuse, so I'm going to leave it c squared. And then we're just going to simplify. So 3 squared is 9. 6 squared is 36. I can add these up. So we'll get 45. And then to solve for c, to figure out exactly how long it is, we'll square root both sides to get rid of that squared. And then I don't know the square root of 45, but I can break it up. And I feel like probably the way to break it up is 9 times 5. And that's really good because I know how to square root the 9. And I can't do anything about the 5, but I can square root a little bit. So we'll have the square root of 9, which is 3. Square root of 5, I don't know. And there you go. So that is the exact answer, which is usually what we want. But if we're talking about like a real life situation, you might want the approximate one. And that's where I just go to my calculator and type in the square root of 45, and it would give me a decimal that's probably like 6.8-ish. And I only know that because the square root of 49 is 7, so it should be a little less than 7. All right, on to the next. So I do have a right triangle. I can use a squared plus b squared equals c squared. This time I can see that one of my legs is unknown to me, and they've called it a, so I'll just leave a there. But then 5 squared equals the square root of 43 squared. So we'll go through and simplify a little bit, like 5 squared is 25. Now over here I gave that little look because the square root of 43 squared, well, the square root square will just cancel out and you're left with 43. That's kind of nice. Now this time though, I can't add up because they're on different sides, so we're going to want to subtract the 25 both sides. We'll have a squared equals, let's see, 18. And then square root both sides. So a is, well, I think I'm going to break that up again into a 9 and a 2. And square root the 9 for 3 and leave the 2. Let's box up my answers. Okay, on to the next. I have a right triangle, so I can do a squared plus b squared equals c squared. I do not know the leg that is labeled with b, so we'll do 10 squared plus b squared equals 12 squared. So 10 squared is 100. B squared is still b squared. 12 squared is 144. And like the last one, I can't add up. I need to get b alone, so we'll subtract. So b squared equals 44. Square root both sides, and then I'm going to break that one up because I can't square root it to 4 and 11. So b will be square root of 4, which is 2. Square root of 11, do not know. There you go. And then last but not least, I have a right triangle, so I can do a squared plus b squared equals c squared. This time, again, I don't know my hypotenuse. I can see that across from the 90. That's the one they haven't filled in. But this one is a good one to look at. So this 2 root 3 squared, we're going to kind of want to put like that with parentheses. I know I haven't used parentheses anywhere else, but there's kind of 2 numbers there, so that's why it's important. Square root of 5 squared equals c squared. So the square root of 5 squared, like we did before, that'll just be 5, like the square root squared cancel each other out. The reason that this one is tricky is, again, because there are 2 numbers there, and you have to fully square it, which means you're doing the number times itself. So really you're squaring the 2, like 2 times 2, and you're squaring the square root 3, so root 3 times root 3. So you really end up here with 4 smashed up against root 3 times root 3, which is root 9, which is 3. So kind of like this last one, I squared the square root of 5. If I square the square root of 3, it's just 3. And they're smashed together, so let's multiply. So we'll have 12 plus 5 equals c squared, so 17. And then we'll square root both sides. Man, 17 is straight up prime, so I can't break that guy up at all. It's just going to stay c squared, or c is square root of 17. Now, when we talked the other day, I said that when you're doing the Pythagorean theorem, if you have all nice numbers, then you get what's called a Pythagorean triple. So a Pythagorean triple is a set of non-zero whole numbers. So like that whole part, that's kind of the important part. That's what I mean by a nice number. A, B, and C, such that if I put them into the Pythagorean theorem, they work out. So like all these ones that I did up here were all examples of not Pythagorean triples because they all had yucky square roots in them or decimals in them. If you think about it that way, they're not whole numbers. So these are some common triples, like 3, 4, 5 is a really common Pythagorean triple. 5, 12, 13, 8, 15, 17. All of these are really common ones. Now, based on the last chapter, we know that we can scale stuff up or shrink it down, and those things are similar. So we can like times them all by 2. So if I multiply all these by 2, 6, 8, 10 is another Pythagorean triple. 10, 24, 26, 16, 30, 34, 14, 48, and 50. And you could times it by anything, or depending on the numbers, like scale them down, like take a half or take a third, although none of these look great to be taking halves or thirds or even fourths. So let's times it by 3. So we could have like 9, 12, and 15. 15, 36, and 39. 24, 45. Oh man, 51. Wouldn't have thought 51. That's fun. And then 21. Oh boy, 72 and 75. So we can use this theorem to determine whether a triangle is a right triangle or not. And that's really talking more about the converse. So I think I'm going to jump back over here now. And let's talk about the converse of the Pythagorean triple, or Pythagorean theorem. So the converse of that theorem is just the flip of it. So when I flip these statements around, I'm saying if c squared equals a squared plus b squared, then triangle ABC is a right triangle. So I totally just flipped the statements around, and it's a little bit better than that even, because if they don't equal, I can also know a little bit more about the triangle. So if c squared is greater than a squared plus b squared, so c is my hypotenuse. If my hypotenuse is longer or bigger than fitting all in evenly, then bigger than 90 means that I am an obtuse triangle. Or if c squared is smaller than a squared plus b squared, so if my potential hypotenuse didn't fit all in evenly and it ended up being smaller, then that angle in there is less than 90, so it is acute. So that's kind of nice, because you can know more about it. You can say something better than just, it's not a right triangle. You can say, well, it's obtuse. So that's kind of fun and cute. So if we jump back here and try this, determine whether the given side lengths will form a right triangle. So my potential hypotenuse here is the 11, because it is the longest. So now it's more like a question. Is 11 squared equal to 4 squared plus 7 squared? Well, so that's 121. We got 16 plus 49 over here, which is 65. So definitely not. And I can put a greater than symbol in there. So we're saying that my hypotenuse is bigger than the sum of the two sides, meaning that that would make it obtuse and not right. So another one here to try. I feel like, didn't we have this on the front? 21. Yeah, so they're all divisible by 3, and they get back to this triple here. So yes, this was one of our triple. Now, you can always show that by doing 75 squared and then 72 squared. Oop, getting ahead of myself. Plus 21 squared. Those are real big numbers. So it's better if you kind of just know those triples in your head, but you're just going to know them from seeing them over and over again. I don't recognize that one as a triple, but if I divide everything by 3, then I do know that 7, 24, and 25 is a triple. So that's kind of a way to maybe know them quickly. This one I can already tell won't be a Pythagorean triple, but it might still make a right triangle. And I can tell because that's square root of 10. That won't make a triple, but it might still make a right triangle. So we'll do 24 squared, potential hypotenuse because it's the biggest, is maybe equal to the square root of 10 squared plus 3 squared. I feel like not. I feel like that's going to be too small again. Like 24 squared, that's real big. I think that's like 600 something. I can't. It's too big. 576. And then the square root of 10 squared is just 10, and 3 squared is just 9. So like definitely not. And this is greater again, so it is obtuse. And then last but not least, this one here. I should have said too, like the square root of 10, I knew wouldn't be bigger than 24 because that's like 3-ish, because the square root of 9 is 3. But I'm thinking about that over here when I'm trying to determine what my potential hypotenuse is. Now, I think it's probably 11, but I should think about what is 2 root 10. Now, again, root 10 I said over here was about 3, like a little bit more, but not 4, because again, the square root of 9 is 3. And a 3 smashed up against a 2 is 6-ish, so definitely not the longest. So we'll do 11 by itself. So 11 squared is something to 2 root 10 squared plus 9 squared. So 121. And then the 2 root 10 squared, we did one like that above. Really, I just like to think about squaring each thing. So 2 squared is 4. The square root of 10 squared is 10. So it's going to be 40 right there. And then 9 squared is 81. Oh, 121. So this does equal, so it is a right triangle. It's not a Pythagorean triple because it's not a nice whole number, but it is a right triangle. So obtuse, right. That one was right because it is a triple. And one last one to try here. I don't know if y'all knew this, fun fact. I didn't know this until a couple of years ago. Well, more than a couple, like 10 years ago. But televisions were measured by the screen length's diagonal. So like when you go buy a 65-inch TV, it's not like how long it is or how tall it is. It's the diagonal of it. So if the diagonal of this TV is 52 inches and the width is 40 inches, what is the height? Well, a TV does make a right angle in the corner. So we can do the Pythagorean theorem because we technically have a right triangle here. So 52 is my hypotenuse because it is across from the 90. So we'd have 40 squared plus, I don't know, the height squared equals 52 squared. Now this one, they do want me to round to the nearest tenth. So 40 squared isn't so bad because I just square the 4 and then the 10. So like square of 4 is 16 and then square of 10 is 100, so 1600. But the 52, I do not know. So 52 times 52 is 2704. Now to figure out the height, I'm going to have to subtract that 1600 here. So we'll have h squared equals 1104, and then we'll square root both sides. Now, they do want me to give an answer where I round. So I'm just going to go straight to my calculator and type in 1104 and then take the square root. So 33. That one's a little bit too big for me to round in my head. So to the nearest tenth will be 33.2. And there we go.